I'm laughing because I can see my dog in the background. I think he's itchy, so he's trying to scratch his cheeks on the on the on the floor thing. Anyways, okay, so more fractions and divisions, and 6 divided by 2/3. So what's gonna sorry. Now I can see his nose right there. Okay, so once again, with division, you will represent both fractions as an area model. Okay. Okay, and once again, one of the first area model, I divided it from top to bottom, so I'm dividing the second fraction from side to side, and I have 5/6 on the side and 2/3 on the side. Okay, and with division, we have to understand what the question is asking you to actually figure out. And for this one, it is how many times do 2/3 go into 5/6? So that's the question that we are trying to figure out. Okay, so same as before, we will find common denominators. In order to do that, we superimpose 2 of the area models on top of each other. So for this one, I would divide this part into 3 equal parts, and for this one, I divide that into 6 equal parts. Okay. And so what we did here was we found an equivalent fraction for both of the fractions, so 5/6. So I multiplied both the numerator and the denominator by 3. So we found that it is 15 over 18, 15 18th. And for this one, we have 2/3. So I'm finding an equivalent fraction for this. And for this one, I'm multiplying both the numerator and denominator by 5. Nope, 6, sorry, 6. My bad, 6. So 18 and 12. So 12 over 18, 12/18. So now we can rewrite our question. So our question is we are only going to look at our numerators. We can forget about the denominators for now. So we can rewrite the question to how many times does 12 go into 15? How many times does 12 go into 15? Okay, so we're going to count. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? So I know that at least 12 goes into 15 at least once. So this is my 1. And this is a really, really cool part. So that means when I have 12 pieces out of these little units, when I have 12 out of 12, that is my new whole. That is my new whole. So which will give us actually an idea as to what we're going to do with the remaining 3 pieces. So I have 1, 2, 3 pieces left, right? But out of what? So when we are considering out of 3 out of what comes into play. So when I have 12 of these sliced pieces, units, then that 12 out of 12, that gives me a new whole. That means I have only 3 out of the required 12 to make a whole. So the answer to this question is I have 1 and 3/12. And then I can simplify by dividing both the numerator and the denominator by 3. So I have, this is 1 1/4. 1 1/4. Also, I can describe how many times 12 go into 15. That was 15 divided by 12. Oops. So I can write it like this as well. 15/12. 15/12. And I can simplify this as well. I know that I can divide it by 3. I know I can divide it by 3, which gives us 5/4. And it's the same as 1 1/4. So you can figure it out this way. But because, so far we did it as we always do. So we found our common denominator by dividing the first fraction into 6 equal parts, and then we did from top to bottom. We divided the second fraction into 3 equal parts from side to side, and in order to find the common denominator, we superimpose the two area models on top of each other. So we found the common denominator by superimposing the two area models on top of each other. So I know that it's 1, 2, 3, 4, 5, 6 on that side. 1, 2, 3. So 3 multiplied by 6, I know that there are 18 pieces in each of the area model. So I know that means my unit fraction, each of these little units, that's 1/18 for both of the wholes, right? So that's how we figured out our common denominator. That was 18, and we figured out that we can rewrite our question, how many times do 2/3 go into 5/6, and we can turn that question into how many times does 12 go into 15. But because we are dealing with 6 and 3, we can do it in a different way. We are still going to be using area models, but it will look a little bit different. So let me show you. Okay. So that part can go. Okay. All right. Okay, so the first part is exactly the same. So I am going to represent my 5/6. Okay, so I'm dividing my whole into 6 equal parts. And because I have 5 sets, I'm going to color in 1, 2, 3, 4, and 5. I'm sure this part is getting extremely familiar. And 2/3. Normally, we would go, because 4, 5, 6, we went from top to bottom. Normally, we would go from side to side. However, in this case, we're going to do something a little different. I am going to actually go in the same way. So I'm going to divide my second whole into 3 equal parts. Ish. 3 equal parts. Okay, so, and I have 2/3. 1 and 2. Okay, so these are divided into 6 equal parts. These are divided into 3 equal parts. What happens if I did that? If I divide each of my 1/3 and then I cut it into half. Now I have 1, 2, 3, 4, 5, and 6. Now I divided my second fraction into 6 equal parts. Now I can compare these two fractions because they actually represent exactly the same model, because this whole is divided into 6 equal parts. this part, this fraction is divided, this area model is divided into 6 equal parts. So what I did was I found a different equivalent fraction for 2/3. So I multiplied both sides, both the numerator and denominator by 2, which gave us 4/6. As you can see, I have 1, 2, and 3, and 4 slices out of 6 colored in. And when I look at my 5, 6, of course, I have 1, 2, 3, 4, 5 colored in. So when we rewrite this question, now that we can rewrite it, how many times does, this one, does 4 go into 5? So what we are doing is 5 divided by 4. 5 divided by 4. So we do it exactly the same way. So I know that when I have 1, 2, 3, and 4, okay, 4 goes into 5 at least once. And that means this is my 1. That means when I have 4 out of 4 pieces, that's my new whole. So I know that there's gonna be a 1 right over here, and I have 1 piece left. 1 out of what? My new whole is 4/4. When I have 4 pieces, I can say, yeah, I have my whole, I have my 1. So I only have 1 out of the needed 4. So 1/4. So I know the answer to the question is 1 and 1/4. Going back to, because remember we are only looking at the numerator to see how many times, I can't talk. So we are only looking at the numerator, so we can rewrite our question into how many times is 4 going to 5. We can, after we found a common denominator, we can forget about the denominator. How many times does 4 go into 5? So we rewrote the question into 5 divided by 4, and of course we can rewrite this as 5/4 as well. So that's one way. There's another way, actually. This is a second way that we can represent this equation. This division. I guess it's also an equation now that I found out an answer. So if you're looking at the denominator right over here, and we know that we can easily find our common denominator because, with our number sense, we can see 3 multiplied by 2 is 6. That's exactly what we did. We had an area model. We had our whole divided into 3 equal pieces. So we took each and divided that into half again, so that now we can represent our whole to be divided into 6 equal parts. So we can always do it the first way, but this is another way that we can represent our division of fractions, especially when denominator is a number that you can see, okay, you know what, I can get 6 if I multiplied 3 by 2, which means we of course have to do the same to the numerator. So that's another way, and I'll be back with more divisions. Thank you.